peeps and friends, as he mentioned. Today we gathered to talk about some blockchain and some technical things, so I decided to do a technical topic that is a bit, how to say it, a bit more advanced. So hopefully in the time we will have some understanding of how those things called diamonds actually work. I don't know, okay. So I want to start by sharing a story, right? So I don't know for you guys, probably most of you are developers. Who is here a developer? Okay, quite a lot of people. So hopefully it's the same story, but when I started, the first thing about blockchain was, okay, it's solid, you know, so you start, you go there, start researching and start seeing how to write a Solidity code. For me, and probably for most, it was just a normal counter, right? So you were incrementing a number, decrementing a number, and so on and so on. So usually we start very small, right? We do very small steps, we do very basic programs, and start learning. But in quite few time, actually very fast, we start to understand that actually the complexity grows very fast, right? So we start learning about standards, other standards like different EAPs, different things that we can reuse that the community has done, and actually our code and our structure grows bigger and bigger and bigger, so it gets very, very complex at the point that MakerDAO looks like this. So it's a set of multiple contracts calling each other. You don't really know what's actually happening. You need to spend a lot of time not only understand the code, but actually understand what's going on. So in the end, we need to understand a better way to design and basically use and deploy in production large and extensible smart contract systems in a way that actually it helps us. It doesn't actually slow us down. So how we'll do that, you will see in a minute. First, let me say a few words, even that they introduced me. My name is Nikolay Angelov, and right now I'm head of blockchain at Nexo. I lead the entire blockchain department. We currently develop multiple blockchain-related products, not only on the safety part, as we are mostly known for, but we are actually entering the decentralized world. So currently we are building multiple decentralized DeFi and not only DeFi products that hopefully you will see very soon. Besides that, I do public speaking. I have done multiple blockchain courses, and I like playing games, even that nowadays I don't have time for that. And here's some context if you want to ask questions afterwards. So how do we design a very large and scalable systems? Well, there's multiple ways, right? There's proxy patterns, there's a lot of patterns and standards. Today I decided to talk about diamonds, as I think they're very powerful in designing huge systems, and I think that they are a bit underrated, right? So hopefully, if you haven't heard about them, if you have heard about them, but you were scared because of the names, about the stuff you mentioned, I'll try to explain them very simple, so in the end, hopefully you can start using them. So what do the diamonds give us that actually will help us design big and scalable systems? The first thing is modularity, so we can split our code in different modules. We can reuse those modules. We can do a lot of stuff. Like we learn about modularity from day one when we start traditional programming. Like, okay, go do different classes, split the logic, decouple it, and so on and so on. It is so-called the diamond facets. We'll see later. The next thing is cohesion. So the idea of cohesion is that we want to not only do modularity and reusability, but actually do decouple them in a way that they can be used in any way, right? In any sort of combination. And one of the most important things is actually upgradability, right? Because actually It's very hard nowadays to upgrade smart contracts. You need to take care of about the photo stuff. And with diamonds, we can actually do very easy upgrades, and we can upgrade only parts of the code, as we will see later. So what are diamonds? And essentially, diamonds are the so-called and known pattern, the so-called bridge pattern. Who has heard about bridge pattern? Anyone? Okay, a few people, nice. So what bridge pattern does is actually, the idea is to spread the abstraction and the implementation. So we want both to live in the separate worlds, and we want to have multiple implementation over the same abstraction, and so on, and vice versa, right? So bridge pattern is used in everyday programming, mostly, hopefully, if you do it right. So diamonds try to achieve the same thing, basically. So what a diamond does is basically you have a user, you have a proxy contract, which is the actual diamond, and this proxy contract delegates calls a logic contract. So essentially, you have one entry point where the user goes, but then you have your logic is somewhere else, right? So what delegate call does, or maybe I should ask who knows what delegate call does? Okay, quite a few, nice. So delegate calls, in simple words, would just copy the logic, the implementation from wherever you point it, and you will execute it in the context of the proxy in this example. So what does the diamonds consist of? The entire magic is done by 4 things: the so-called facets, the storage, the cut. We understand later what these things, what those things do, and the loop. So facets. Well, the idea about facets is basically the diamond. Every single side of the diamond has the so-called facet, and currently it just represents a different logic implementation. So facets are essentially smart contracts which can have a single function. They can have multiple functions, but they hold only implementation, right? So the idea is that instead of having in your main contract every single function written, basically deploy a single facet for every function you want to execute. That way, when you start upgrading, you can upgrade only single functions. You don't need to upgrade every single, the entire contract and care about stuff. Sorry. So essentially, then you end up with this picture. The user calls the proxy contract, then the proxy contract knows based on the call where it should go. Should it go to logic contract 1, 2, or 3, or whatever, maybe a million contracts with different functions. So the facet, the diamond, the main part, actually knows how to resolve which facet to use, right? And it's very simple. It's actually done the same way the Solidity does it. So when in normal Solidity, when we try to execute a function, we do a signature based on the entire signature of the function. We hash it. We take the 4 bytes of the function, and that's how we call it, right? Here it's the same, but instead of actually calling the function, we have a mapping, and this mapping holds the signature of the function to an address, and the address is basically the contract where the actual implementation of the function is. So essentially, you have a single mapping that has all those functions that you want to actually execute and where they live, and on which address are they. And you can upgrade it very easily, of course, because we can just go and change the pointer to the function to another address. You can do, as this picture shows, you can do cross-function facets, but you'll understand that a bit later. So that was one of the things that was main part of the diamonds, and that's the facets that store actually implementation. So we have the implementation there, but we need to have actually a storage, right? So at first, the storage was maintained in every single facet, and it was very hard to actually maintain, upgrade, and do stuff. So So they introduced something called state variables. Actually, Solidity introduced the way of actually storing data on the so-called storage slots. So what Solidity gives us is the ability to basically say, okay, I'll have my data at particular space in the storage. So here is an example. We calculate the position. Position is basically a hash where the data will live. It's very important actually for the hash to be unique, so you don't end up having to replace an old structure. So let's say if I have an array at point 1, then at some point I reassign this slot to another array or another data type. It will overwrite what was there. So usually how people do it, they have storage contracts, and usually one contract exists for one data set, for one structure, and usually they follow the normal tradition patterns for naming. So here you have your company, projects, which is actually a namespace, and the actual structure. So you have like company, namespace, actual data structure. So then you have the structure definition. It can hold any type inside of it, and then you have a simple getter that basically returns the position of your structure. So what do we need to avoid when we use storage slots? It's actually the same namespace. Again, if we in some way try to do same structures in the same place, it will be overwritten. If we reuse the storage slot pointer, it will be overwritten. So we need to take care of that. It's not very hard to avoid. Just do correct naming, right? And do it uniquely. And the other thing is do not nest structures, right? So in the structure, your data structure, don't put another struct type, because it is impossible then to actually update it or maintain it or remove it. So in the base scenario, don't put nested structures inside your data types. So how our picture now looks like with facets and storage, we can see we have a few examples. Can I do that? Yeah. So we have the data, and we have code, which is actually a facet, right? So we can see that we can do our cross combinations, like a facet A can read data from any data storage, code D and facet D can read data from multiple other storages. They can share storages, you can share facets, logic, and whatever you want to do that. So you have all those ability to basically select a certain function and run on a particular data set. You can run multiple facets in the same transaction. You can gather data from different storages in the same transactions as well. So one of the main important things is that actually for the facet to be able to have a storage, it needs to inherit from the storage contract. So essentially when you code, you need basically to say, okay, my facet will have this storage, right? The other thing is, and all of those things allow us to have better permissionless system, right? Right now, we are mostly using like only ownership. We have some other permission system, but it's not very scalable. So without the facets, storage, and all the playground around those things, you can basically create very complicated permission system which can be managed by either you or the user or whatever you design. So we passed the two main points. Now, how do we manage those stuff, right? So there's something called a diamond cut. Usually diamond cut is a managing interface. It's another smart contract. The idea behind it is actually to manage all those relationships. So it can have it can manage faucets, it can manage data storage. So what it can do is basically add. So you can add a particular function very easily. and that's one of the upgradability parts. You don't need to replace entire smart contracts. You basically call a single function that basically says, okay, add this another function, this other facet to my implementation, and it will just work. It can remove it, of course, and it can replace it, so you can play around it. And one of the other things is that it can actually perform multiple actions in the same transaction, so I can add 6, 10, 20 functions in a single call. Here is some like simple example of the interface of how the diamond cut looks and what things it needs to implement. It works, of course, with code data. There is the init address, and the code data here is actually used to initialize if you need to initialize the specific faucet. So if you need to have a faucet which has some data in it, like let's say only owner or implementation or whatever, you can pass in this code data when you add the faucet to actually trigger the thing to basically initialize it. So we have all those stuff, the cut, the faucets, the storage. Now how do we manage those things, right? In reality, we saw the maker picture. It was looking scary. Here, it might look scary at the start, but actually, it will be better when you start understanding it. So we have something called a diamond loop. The idea is that is basically a dashboard. So there's websites already doing that. Sadly, Etherscan doesn't do that. Is to actually be able to actually read diamonds and to read them in a way that when I provide my entry point, I'll have the ability to see where my functions are located, which storage is actually held in those functions, and basically when was the last time I upgraded a particular function and everything. Hopefully Etherscan will actually start using the loop. It's very simple. It has these 4 view functions. It's actually, because they're our view, it's actually very cheap to use. Of course, it's free. And the other thing is that it's full with events, so everything happening to adding facets, removing, doing stuff with the storage actually triggers events, so you can track all those stuff. So who is using diamonds? Currently, it's used by Avagochi and PyDAO. Avagochi is quite big, PyDAO not that much. OpenZeppelin is in talks to start having like examples in their libraries, and hopefully many more will switch to diamonds, and we are building it. So we are building few systems using diamonds. If you're curious, I'll be happy to talk about it with you. And I know it was quite fast, but I decided to leave more time for questions and discussion. So I'm very happy to answer any questions related to the diamond standard. So. They are bringing the microphone.
Thanks. So you said at the beginning, I think this is quite right, that it's an opportunity for improving software engineering practice for dApp developers. I mean, one of the things I thought you might have said was that it would allow a way of having shared libraries between project, because that, in a sense, that's the killer problem with, and I think with Ethereum particularly at the moment. You know, everybody copies code and modifies it, and instead of saying, "Here's a standard library, just call this library." Now, are people using it like that at the moment? And do you think there's a possibility for that to happen in the future? If not.
Yeah, so I thought it would be understandable. It's a completely modular system, so any facet can be used not only by myself if I coded it, it can be used by anybody in the room, right? They can implement their own storage. For that, it's completely fine. So every single part of the code, basically every single function and facet can be used by anybody in the world. And the idea is, yes, to go to a modular system where we can reuse stuff, we can be happy with what we have, and it actually reduces deployment cost a lot. So let's give you an example. If you have a smart wallet, you know, if you deploy it with normal proxies, it will cost like at least 8-9 times higher than actually using the diamonds, because the diamonds you don't need to replicate the entire logic. The other thing is that because it's modular, it's not only the developers that control the modules. So let's say if this is again a wallet or some other whatever dApp that introduces that the smart contract is basically to the user can control and change those functions. So you'll have the same way like we all control our iPhones or telephones. Just go and install an app. It will remove the faucet. Go install it back. The faucet will be there, updated, whatever, you know. So you have a bigger, very large and scalable system that you can give the power to the people, or you can keep it to yourself, but still you can play around it. Do people use that? I have seen some tries to use them, but not in a way to use it as a diamonds. They usually try to do normal proxies with some sort of modules. They try to use libraries again, but it's a long road. Hopefully people will wake up at some point, you know. Again, some standard development standards and patterns have been introduced in 19th. They have been started being broadly used in 2005, probably 2010, so it takes time, you know. Hopefully that answers that question. Yeah.
Hey, thanks for the talk. Do you have any recommendations how to prevent storage collisions, other than that keeping a different namespace? Because if you have a huge team working on different facets and facet storages, what's the best way to prevent storage collisions? Yeah.
Well, honestly, currently I think the best is just to be careful. Is there other ways? Yeah. Some people use some random generation for storage slots. Other people do other stuff. But I wouldn't risk it with random stuff. I wouldn't risk it with just how Solidity does it, you know. Like even how Solidity does it is very riskier. In that case, you shouldn't do it. So just in at least my understanding, I might have missed something. Just taking care about like namespaces, it should be fine. Again, this is used in everyday development. So if you go and take, let's say, a Java or C# or whatever library you download from the internet, it's namespaces everywhere. That's the way that the community has decided to do it. Yeah.
Thanks.
Hi. I wanted to ask if there is actually a gas impact for calling all these contracts. I'm not very familiar with Solidity, but in the Cosmos world, that has been tried, and there is a big impact to that.
Actually, the diamonds in general are very gas optimized, so actually, in most cases, it might be cheaper. Of course, in some cases, it might be more expensive, but overall, when working in those kind of scales, it will be probably cheaper. Like just the deployment cost can be very, very cheap compared to deploying an entire system. Again, it depends on the scale, right? So if you have let's say an entire app like Avagochi, which has tons of multiple parts, games parts, like items and stuff like that, it will be very hard to deploy out this logic for every single player, right? And of course, there's another optimizations there, but in the end, like the diamonds will make it so cheap for just spawning a player and deploying his own stuff that probably even some of the interaction is a bit expensive. He will be saving money overall. Yeah.
But not for the actual users.
Sorry?
but not the actual users who are calling the contract.
But usually most of these games, the entire deployment, like if you go and register to have a GoChain deploy your, let's say, player, avatar, whatever, you're paying the gas, right? So in the end, like it will be something like, okay, I'll go to the website and register, it costs me $50, or I go register with diamonds and it costs me $4, you know. Actually, I can pull you statistics about that. Because again, as I said, we use diamonds, we do a lot of deployments, and our diamonds deployment is at least 8 to 9 times faster. So something like the traditional proxy method, we'll be using around maybe $1 million gas for the entire thing. With diamonds, it costs under 200,000.
Thank you.
Other questions? Yeah, Milan.
Can I?
I can call you by name.
Okay, so my question is, how this affects your workflow? Is the tooling good enough for you to be able to debug and to develop smoothly as, like, however the standard way so far was?
Yeah, so it's, of course, it's a bit more complex, you know. It's actually the development complexity is a bit higher at the start, but when you design your modularity, if you used just in traditional way, you design your systems in that way, it's not that hard. The tooling is okay. Actually, there's companies doing audits as well. So for one of our products, we are waiting for 3 auditors to complete the audit. So as you can run pretty much any standard tooling that exists. Of course, you can integrate the Whoop to further review your diamond systems and stuff. Like this is not my laptop. I would have shown you a demo. I can show you afterwards. Yeah.
Thanks.
Other guys, questions? I don't know if we have time for questions. Yeah. Okay. Anybody? Well then, thank you. If you have questions, we have a booth there. Come say hi and ask me anything. Yeah, thank you.